Hello, class. Welcome to Unit 2 Notes, Lesson 3. We're working on IXL B3 for this one, which is describe the intersection in a plane. So all of these happen in a plane, so these are coplanar, and we're going to take each one of these and take a look and see what it could be. There's only one answer here that makes sense. The rest don't make sense, so let's take each one by one. So let's take a look at what the intersection of a circle and a square could be. So here we have a circle, and here we have a square. It's not really a square. That's a better square. And the the question is, what could the intersection of a square look like? Could it be four lines? That's not really possible because they don't intersect at lines. They kind of intersect at, looks like points or arcs, right? Looks like there's only points. Could it be four arcs? Well, if I shrink this down, it intersects. We could break it into four arcs, but that doesn't mean it intersects at those locations, right? Let me get a perfect square because this one I adjusted. Let's see if I can. There we go. And so what we can do is we can shrink this down. Might be easier to shrink the circle. There we go. For line segments, no, remember, this one's going to be 4 points. Yes, we can intersect to make arcs, but it's not the full intersection, right? The square doesn't lie along this arc, and it doesn't lie along this arc, and it doesn't lie along this arc, and it doesn't lie along this arc. It does break it into arcs, but the intersections where they both lie fully 100% of the time is right here. And so that's at 4 points. All right. The intersection of a circle and a triangle then can be how many points? Well, normally you would think 3, right? So you're thinking, here's what I'm thinking. I'm thinking that we're going to draw a circle. You know what? I'll label these. So here's 1. Here's 1. Here's 2. Here's 3, because I don't have much space there. Here's going to be 4, and then this one would be 5. All right, so here's 1, here's 2. So I'm thinking I'm going to draw a triangle, and I'm going to intersect it. Oops. I'm going to intersect and get 3 points, but that's not an option, and I'll show you why. Nope, that's not what I want. I want a really nice triangle here. Are we going to do it? Okay. Well, this triangle, we can do 3 points, but what I'm actually thinking now is if I just bring the triangle a little bit more over here, I can actually get 6 points. There we go. I see it now. 1, 2. Instead of on the vertices, it's actually intersecting the line segments of it. So that's 3 and 4, 5 and 6. So the answer here is yes, 3 is an answer, but that's not part of what they gave me. But 6, I can make that happen. So 6 is the answer here. Okay, this is what answer makes sense out of the answers they give you, not what is the one and only answer. All right, so a line can intersect a regular pentagon in how many points? So a line can intersect a regular pentagon. So let me draw a pentagon. There's a regular pentagon. 5 congruent sides, 5 congruent angles, and now we have a line. And I'm going to draw a line. Whoops. And so now I need to see how many points. Well, I can get 1 point. I can intersect it at a ray, a line segment, and I can get 2 points, and that is all I can get. I can only get 2 points no matter how I intersect it. So 1 and 2. So my answer here for this one is 2 points. All right. Number 4, let me just move that over. Number 4, a line segment can intersect a circle in. So what can a line segment intersect in? A line segment. A line segment, which I'll grab right here, can only intersect a circle at 2 points, or like 1 point maybe. It can't intersect the whole circle because only a circle can intersect a circle if they're congruent. You know what? This answer is just 2 points. Right? For these, you're going to have to draw some of them out and see what works and what doesn't. All right, so now the next one, intersection of a square and a regular hexagon. All right, let me draw the regular hexagon. Oh, didn't recognize it. I don't blame it. That wasn't the best picture. Nope. Yeah, let's try again. Come on, come on. We got this. Oh, almost. Okay, let's see. Here we go. Keep working and you'll get it, right? Okay, and then a square. Okay, so for the square, looks like I can intersect at, what can I intersect at? 2 points. Yeah, that can work, right? See what I just did? Can I do it at a pentagon? No, because I would have to have a pentagon and a hexagon for that to work. How about a parallelogram? No, I would need a parallelogram to intersect. Yeah, 2 trapezoids. No, so this answer is just 2 points. If I find an answer that works, I'm going to use that answer. I'm getting, yeah, hold on one sec. This is the pencil is messed up. All right, let me just move that. Let me erase this. It's like 10,000 points it put in it. All right, and let's try this again. There we go, a nice smooth point. Boom. So this answer is 2 points. All right, a triangle and a ray can intersect where? So I'm going to draw a triangle, and I now have a ray. And where can this intersect? It can intersect at a couple of points, maybe just 1 point. I don't see any of those. A pentagon, no way. A rectangle, no. A line, it can't be a line because a ray doesn't go on forever. But you know what? It can intersect at a line segment. Check that out. That whole thing right there is a line segment on this ray. So that is my answer, a line segment. All right. All right, the next one. A ray can intersect a regular hexagon in, so here's my hexagon, and these will start to go faster now that I have most of my shapes drawn. My figures here drawn. All right, so a ray can intersect at, again, we can't do a line because it doesn't go on forever, in both directions. 6 points. No, I can get like 2 points off of this. You get like 2 points. 4 points, no, but you know what? How about a line segment? And whoops, that works for me. Looks like right there is a line segment again. So the answer, line segment. Whoops, this isn't working. I don't know why you have to repair it each and every time here. Okay, two lines can intersect in just 1 point. Two lines intersect at 1 point. Unless they lie on top of each other, then they are a line. But we're gonna grab that. So here's two lines. And they intersect at a oops. And they intersect at a point. Okay? The intersection of a regular pentagon and a line can be, the intersection of a regular pentagon and a line can be, oh, what did it say, pentagon? I have one right here. And look at, we already have that answer, 2 points. Let's see if that's also an answer that they have here. So an intersection of a pentagon and a line can be, yeah, it can be 2 points, but what's another option? Well, it could be a line segment. If I move it right there, that could also be a line segment. And quickly, nope, let me erase that and that. And here's my line segment that's going to intersect at from there to there. So that's also another option. Again, it's based on the given options here. It's not a line, array, or triangle. So that's a line segment. Two line segments can intersect in, again, if two lines is in 1 point, two segments are also in 1 point. And all I'm going to do is I'm going to copy this over because these are lines. Let me make them segments now. And there we go. So here's my line segments. They have these two endpoints, and they intersect at 1 point. All right, and the last one, the intersection of a circle and a line segment can be, well, I had that right here. Here's a circle and a line segment. And notice my last answer was 2 points, and now it's going to be 1 point because I'm going to move it all the way over to the edge over here. And now I only have 1 point of intersection right there. Okay, and so this one is a point. So each one of these are a little different. We can work together on them, but drawing them out will really help. And now you also have this cheat sheet, right? So for this lesson and the previous lesson, you have cheat sheets where if they ask you the same question, you can just use the answer that you found in the cheat sheet by watching this video. Okay, so IXL B3 describing intersections in a plane, and good luck.